root 2 over 2. Missing a parentheses. So what do you think the answer is going to be here? What, according to the formula, it should be what? Negative root 2 over 2. Question, is it? Let's see if it really is. So here, you're saying where on the unit circle is my y-coordinate negative root 2 over 2, but I can only live over here, right? So what would we get here? What angle would give you that? You'd have to be down here, wouldn't you? That's where you have the y-coordinate negative root 2 over 2. And what angle is that? Negative pi over 4. So this is now saying, what is sine of negative pi over 4? Right? And so you start with a brand new circle and you say, okay, if somebody's asking me where negative pi over 4 is down here, right? And if it wants the y-coordinate, because it's sine, it's going to spit out what? Negative root 2 over 2. So it works, right? So far things are looking pretty darn good. I don't know why he's calling this dangerous, right? It turns out this one will always work. Okay? This one is the one that's dangerous. All right? This is the one that's dangerous. This one you can trust will always work. Now there are some restrictions for this one. Let me tell you what the restrictions are. The x that goes into this, x has to be an element of the interval negative 1 to 1. So this means x belongs to the interval negative 1, 1. Think about that for a second. The x is going into the inverse sine function first, right? And didn't we already say that the inverse sine function had as its domain values between negative 1 and 1? Yeah, so if someone were to say, hey, what's sine of, like this would be a good thing to get someone with. What's that? Undefined. This is undefined. This would not be 4. Because this 4 going into the inverse sine function is not defined. So that's the only kind of thing you have to worry about. As long as the number here is between negative 1 and 1, that property works. Now let's take a look at the dangerous one. This one, that's a face screaming, I guess. Ah! This is the one you have to really be careful with. The first example I'm going to give you is going to make you think that it's not dangerous. So I'm going to start out arcsine, and then I'm going to do sine, and then I'm going to do pi over 6. The answer should be, according to the property, if you just read the property out without doing any real thinking, the answer should just be pi over 6. Agreed? Now let's see if it is. So we start with the inside. Sine of pi over 6. That is saying to me, go to pi over 6 and give me which coordinate? The y-coordinate. So what is the y-coordinate at pi over 6? What is the y-coordinate pi over 6? 1/2, right? So this at pi over 6, go there, get the y-coordinate, it's 1/2. Now I want to take arcsine of that. So now I go here. Because it's arcsine, I cut off this part, and I'm asking myself, at what angle is the y-coordinate 1/2? Which is? The angle is pi over 6. And so we get the answer. And everything looks great, doesn't it? I mean, that worked. Are there any questions? So now time to give you one that doesn't work. The dangerous one. Oh, no, there's plenty that can be dangerous. All right? Here we go. Let's do this. How about arcsine of sine of 3 pi over 4? That looks like that wouldn't cause us any issues. And that the answer should probably be, according to this property, what? 3 pi over 4. Question, is it? Well, let's check it. We already know it can't be. And here's why it can't be. This stuff right here is coming out of the arcsine, isn't it? An arcsine only spits out angles between negative pi over 2 and pi over 2. And 3 pi over 4 is not in there, right? So that can't be the answer. But it does have an answer. So what we have to do is start with this piece first. We're going to go to our unit circle. We are going to look at the angle 3 pi over 4, which is right here. And we are going to pick the y-coordinate off because it's sine, right? The y-coordinate here is what? Root 2 over 2. So this piece right here is root 2 over 2. So I want to know what arcsine of root 2 over 2 is. And now I start the problem over. And I say to myself, arcsine can't be here. Where is the y-coordinate root 2 over 2? Where is it? Where is the y-coordinate root 2 over 2? Here, pi over 4. Right? That angle is pi over 4. And therefore the answer to this is not 3 pi over 4. It is pi over 4. And that means this property didn't work, right? So whenever you see something like this, my recommendation is to actually go through this process of determining, first of all, what is that? And then go back through the inverse trig function and come back there. Do y'all see that? So this property, when does it work? The only time this ever works is if the x you plug in, have a guess? If the x you plug in is what? Between negative pi over 2 and pi over 2. See, if the angle that I plug, see this angle 3 pi over 4 was outside of this restriction? So if I pick an angle that's outside of that, then it's never going to spit that angle back to me. If the angle is inside here, it will spit that angle back to me. I always get people on tests with that problem. I'll give them, arcsine of sine of 7 pi over 6, and or I'll, just something, and they'll just put 7 pi over 6, and they won't go through the work.
It could be negative pi over 2 as well, right? It can be equal to that.
What could?
It have to be between for 2.
It has to be between these two.
It has to be between. It can't be. Oh, okay.
For the property to work, for you to just be able to say, hey, I want to just take that x and put it here as an answer, this x better have been between here and here.
And it can't touch those.
It
It can touch them.
Yes, it can touch them. What was your, yes? Yep. All right, how about the cancellation properties for cosine? Well, that means there's a couple of more. 3. Cosine of cosine inverse of x equals x. And that is so long as x is between negative 1 and 1. Okay, this thing is almost out. It's starting to die on me. I'm going to get to the office and be like, hey, this thing's run out. And they're like, oh, they're going to be like, oh, we don't have refill ink for it. I bet you anything. Oh, we didn't even know those were refillable. I bet you that's what they're going to tell me. All right, that's that one. And then the fourth one is cosine inverse of cosine x equals x so long as x is between 0, and pi. Property 2 and property 4 are the dangerous ones. We have some time. I'd like to give you a few examples to work on your own. Well, with each other. How about that? Let's try this. I want to see how you do with this. What's cosine of cosine inverse of 1? What's cosine of cosine inverse of negative 1/2? What's cosine inverse of cosine of pi over 6? And what's cosine inverse of cosine of negative pi over 3? All right, so there's 4 examples. I'd like for you to work through these and see what you get. I haven't given you a single example of these, have I? I haven't given you a single example, but I want to see if you can make the connection between the sine and cosine. And the only difference is you're looking at x coordinates instead of y coordinates, right? So when you have all 4 complete, raise your hand and I'll come by and check to see if it looks good. I were to say, what is cosine of negative pi over 3? You would just tell me it's 1/2, because you would go to negative pi over 3, you give me the x coordinate, and you would say it's 1/2, right? So now what you're going to be doing is cosine inverse of 1/2. That is inside the domain. And so now what you're doing is you're cutting off the bottom now, and you're saying, where is the x coordinate 1/2? And that happens, positive 1/2, not negative 1/2. That happens there, right? 1/2. And that angle is pi over 3. So you get pi over 3 instead of negative pi over 3. How do y'all feel about this? Got about 12 minutes. You'll have some time to work on this at home also. We need to talk about arctangent. All right? This will be the last one. All right. The inverse tangent function.
Are there dangerous stuffs with this one too?
That's a good question. I wonder if we do get anything dangerous with this one.
Both of them are dangerous.
Let's take a look at first the graph of tangent, because that's the way we started all these. We need to figure out where to cut the domain in order to make it have pass the vertical and horizontal line test. But tangent was kind of a very unique looking function. At negative pi over 2 and pi over 2, we had vertical asymptotes, didn't we? And then the graph went like this. Remember that graph? That was the graph of tangent. And then it repeated itself. It did that again, and then it did it again, and back here it did it, right? Yes? So with the tangent, can you tell me about the output? I know with sine and cosine it was negative 1 to 1, right? But with tangent, what can you tell me about the outputs? It's negative infinity to infinity, right? Every possible output is possible. So this could be any number. Any number can get plugged in to the inverse function, any number, right? Take any number in, and it's going to spit back an angle. Where should I take my cut so that I will pass the vertical line test and horizontal line test? What seems like the most natural place to cut it?
0 first one.
Where? 0 to where? To pi over 2? That would pass vertical line test and horizontal. But does it include the entire range? That only includes from 0 up. So why don't I go and get these also? I go from negative pi over 2 to pi over 2. I will get the entire range. It'll pass vertical. It'll pass horizontal. The difference, though, is I cannot include negative pi over 2, and I cannot include pi over 2 because they're not, the function's not defined there. So my restriction here is going to be negative pi over 2 to pi over 2 with parentheses around those instead of brackets. And that means what I'm doing is I'm basically erasing all of these other periods of the tangent and only looking at that one period. That also means that when I'm looking at my answers to come back, right, inverse tangent is going to spit out an angle. And that angle has got to live in almost like the sine, right? Almost like sine between pi over 2 and negative pi over 2. It just can't include negative pi over 2 and pi over 2.
So nothing includes negative pi over 2.
Not the tangent, not the inverse tangent, yes. does not include it. All right. Let's see if we can do a couple of examples of this. What would arctangent of 1 be? Now this is harder than sine and cosine, because with sine we looked at the y-coordinate, right? And with cosine we looked at the x-coordinate. But tangent by its definition is the y-coordinate divided by the x-coordinate. So what this is really asking for you to do is look on your unit circle, do not look in these quadrants, and tell me where the ratio of the y-coordinate divided by the x-coordinate is 1. 45 degrees, pi over 4. Right here, because root 2 over 2, root 2 over 2, the ratio of this divided by this is 1. Y over x is 1. And therefore, the angle corresponding to that is pi over 4. Or 45 degrees. But as you can see, I'm not using degrees, am I? Very much at all. So arctangent of 1 is pi over 4. Next example. What is arctangent of negative root 3? Now, am I allowed to plug negative root 3 into the arctangent function? Arctangent. Its domain is everything, isn't it? So this is valid. So now you have to go and you have to look at the unit circle again, and you have to try and figure out, only allowed to look in those quadrants, you have to figure out where the y-coordinate divided by the x-coordinate is negative root 3. Right? That's going to be a little harder to do. We might have to check, right? Let's see. Let me bring this circle up here. I'm not allowed over here, right? Can you tell me right now, can this answer come from the first quadrant? Why not? It's negative, right? This is a negative root 3. So when I divide my y by my x coordinate, it has to be negative, which means one of them has to be negative. And here, both the x and y's are positive. So I could right now also eliminate this as a possibility, right? Because this is negative. And then I only have 3 points to choose from if it's going to come off one of my common points. It's either going to come from this one, which is root 3 over 2, and then negative 1/2, or it's going to come from this one, which is root 2 over 2, negative root 2 over 2, or it's going to come from this one, which is 1/2, negative root 3 over 2. It's got to come from one of those. If it's a nice angle, it's going to come from one of them. It's not this one, right? Because that would give me negative 1. So it's not that one. So it's either this or this, right? So let's try the first one. Maybe we'll get lucky. If I try the first one, and I take the y-coordinate and divide by x, why am I doing y divided by x? That's the definition of tangent, right? So do that, and then I'll multiply by the reciprocal. We've done that so many times, I think that's okay. And then I'll cancel the 2's. I get negative 1 over root 3. I'm going to rationalize the denominator, only because in the book, when you're doing your homework, you'll probably get something that looks like this, so I want you to recognize it. If I multiply this by root 3 on top and root 3 on the bottom, I'll get negative root 3 over 3, won't I? Across the top, across the bottom, that's this. That is not this. So it's not that one. Okay, so let me try this one. If I do negative root 3 over 2 over 1/2, then negative root 3 over 2 times the reciprocal, boom, it's there. That's it. That's the one. So what is my answer? This is the one. This is the winner right here. What is my answer? Negative pi over 3. Negative pi over 3. Because remember, we were dealing with an inverse tangent. Inverse tangent can only be between pi over 2 and negative pi over 2. You cannot come all the way around. So my answer will be negative pi over 3. Does that kind of make sense? I have like 2 minutes. Okay, so I have 2 more cancellation properties for tangent.
Dangerous ones?
Yeah, so let's see if any of these are dangerous. This one right here is okay. And it's actually, this is the best one out of all 6 of the cancellation properties we have. This is the best one. Because the x here that goes into arctangent, remember I drew that picture a second ago and I said when arctangent goes back over, that its domain is negative infinity to infinity. So this works for all x. You never have to worry about a restriction there. When arctangent gets the x first, you're guaranteed it's going to spit out the same x. All right? This one, on the other hand, only works if x is an element of negative pi over 2 to pi over 2. So if we have, I know I'm out of time here, if we had arctangent of tangent of pi over 6, what would the answer be? Well, is pi over 6 in here? Yes, right? Pi over 6 is in here? So the answer would be pi over 6. But if we did arctangent of tangent of 11 pi over 6, that would not be 11 pi over 6, because 11 pi over 6 does not live in here. So you would have to go through and do like that 4th example I gave you to do on your own. You would actually figure out what's tangent of 11 pi over 6. Figure out that answer and then do inverse of that. I'm out of time. I can't go any further. So try your homework on this. We'll come back next week. And we will we will continue with inverse trig functions.
Can you do that? I gave you the one without the.
Yeah, okay.